Let's see here. Trying to remember where we finished up. So we did those. So we're starting here. Awesome. So what we're wanting to do here is sketch the graph of each set of numbers. So we're actually just wanting to sketch the graph given set builder notation. Now as we look at this first one here, the set of all real numbers, x is a part of the set of all real numbers, x is a real number such that 2 is less than x is less than or equal to 5. Really, this first part, especially with graphing on a number line, is just saying we're using the whole number line. Any point on the number line could work, but we only want the points that satisfy this condition, or really just graph that inequality. That's all it's saying. 2 is less than x is less than or equal to 5. So we have a bounded interval. And the two endpoints of said interval are 2 and 5. So our two circles, one of them is going to be at 2, the other is going to be at 5. Now we need to figure out if one, both, or neither circle is going to be filled in. The 5 is equal to, yes? So that tells us that we have to fill that circle in. Because if it's equal to, it means it's included. Is the 2 included? No. Now we need to figure out where we need to shade, yes? Where would we shade? Between the two, yes? And that's it. If we're not sure where to shade, we can always use something called test points, test numbers. One of them we could pick would be, say, 4, and I'm going to replace x with 4. And then just make sure it works. Is 2 less than 4? Yes. So that's true. Is 4 less than or equal to 5? So that works, so it should be included in the answer. That's all a test point is. If we wanted to say pick -2, we can go 2 is less than, -2 is less than or equal to 5. Is 2 less than or equal to 5? Yes. Is 2 less than -2? No. So that means that that part of the graph is not included in the answer. We can't include it because it does not make the original statement true. That's all test points do. We check a point and see if it's included or not. If it is, we're shading that area. If it's not, we don't. Questions on that? Does that feel like a proper math procedure of what we would do? Yes, no, it's kind of weird. Funny enough, for inequalities, higher degree polynomial functions, rational inequalities, this is how we check it. This is actually how we find the shaded regions. We find key points where it would be 0 or cross the x-axis in a two-dimensional graph, and then check points to see where it is included and where it's not. And it works out very nicely. Let's look at the next one. For all real numbers such that x is less than or equal to 0 or x is greater than 4. Since it is an or statement, we have both. Both are going to be put on the graph. That's nice about or statements. We can just throw them both down. Doesn't matter which one we do first. I always do whichever one's listed first. X is less than or equal to 0. So one of our points is at 0. Would it be included or not? Yes, because it's equal to, so we would shade in. Are we shading to the left or to the right? Left. If we're not sure, we can always pick a test point. Is -2 less than or equal to 0? Yep. We're very used to them going in opposite directions. They don't have to. They can go in the same. They can go towards each other. Really, we're used to them going away from each other. They can go towards each other. There's nothing against it. X is greater than 4. Well, we know we're going to put a circle at 4, yes? Opened or closed? Open, it's not equal to it. Shade to the left, shade to the right. Because we want all the numbers bigger than it. So we're going to the right. Because 5 is indeed greater than 4, so we're shading towards 5. Questions on this here? Sketch the graph of the set of numbers for all real numbers x, such that x is less than -2 or x is greater than 0. X is less than -2, so we'd have a circle at -2. And we would definitely fill it in, yes? No, it's not equal to it, so we don't fill it in. Then we shade to the left, because we want less than. -3 is definitely less than -2, yes? That's it. X is greater than 0. So we have a circle at 0, yes? Shade to the right, shade to the left. Yep. That's it. Questions on this here? We're ready for the next one. Now the next ones are going to be, at least the answers are going to look more like the answers you're going to turn in on the homework. Because you can put a 0 point and kind of do a scale and actually know where things are. The only thing I'm asking is you give me the relevant information. So if we look at the first one, number 4, for all real numbers x such that -6 is less than x is less than or equal to 2. This is a bounded interval because we have 2 endpoints, yes? What are our endpoints? So one of our points would be, and the other would be. And it is not wrong to put also a spot at 0, so we have relative reference point to where 0 is. Any of that there? You can put it. There's nothing wrong with it. I'm not asking for it. Because really, we're wanting to graph -6 is less than x is less than or equal to -2. That's all we want. That's all it's asking for. We're going to put 2 circles. Is either one of these filled in? Yes, -2. Where are we shading? Yep, that's it. That's all you'd have to give me for this answer. Draw a number line, give me the 2 points, shade. Now, if it had just said -6 is or x is less than or equal to -2, we do -2, we shade the correct side, that's it. We're ready to look at number 5. For all real values of x, or for all real numbers, such that x is less than or equal to 0, or x is greater than or equal to 10. So if we look at the first one, 0, we'd have a circle. Shade it in because it is equal to it. Then we would shade to the left. If we didn't have the or x is greater than or equal to 10, that just asked for x is less than or equal to 0. That's all we need. We graphed it, didn't we? However, we do need the other half. Because 10 would be shaded. And then we would Stay to the right. That's it. One thing I will say, especially with putting the numbers or doing this here, smaller numbers have to be on the left, bigger numbers have to be on the right. We just need to place them in the right order. That's part of the reason we do put a 0 or put some of the other numbers, is just to make sure we have them positioned correctly. Any questions on these here? We're ready for the next piece. We're actually going to write in set builder notation. It seems like there's a lot to it, but we're looking at the three main pieces. One of them is our bar. Because for set builder notation, we have brace, our type of numbers, such that description. Now, the types of numbers that we're looking at here is the set of all integers. That's our number type, yes? So when we start this set builder notation, we have brace, x. Now, if this had been the set of all real numbers, we can do what? Brace x bar. We don't have to specify anything. That is understood to be the set of all real numbers. However, they did not say we were talking about real numbers. We are talking about integers. So we say x is an element of the integers, x, e, and then we'll use our symbol for integers, our z, with that extra line. X is an element of the integers. Have we described the type of numbers? Yeah, that described them, yes? Bar, such that. So we finished the first half. Now we need to describe the type of numbers. Greater than 5. Now with this here, we need inequalities. We have to have inequalities. We cannot put interval notation and set builder together. If they give us interval notation, like the next one, we've got to convert it to an inequality. Now this one here says it's what? Greater than. Since we use x to start with, we're still going to use x. So we're going to say x is what? Greater than 5. That's it. Questions on this one here? Now, me and the book differ on stating it, and it's not that I'm right, it's wrong, I'm right. The way that they do this, and I find it a little much, is they start here at brace x bar, the set of all real numbers, such that x is an integer and x is greater than. I don't want to write that. I don't know about y'all, the fact that they literally just wrote out x as an integer. We can say the exact same thing with x as an element of the integers. I'm a mathematician at heart. If I don't have to write all that, I'm not going to write all that. The fact that that says the exact same thing in a lot less words. Questions on A? We ready for B? We want to write this interval in set builder notation. So negative infinity to negative 1 or negative 1 to infinity. So we will need to convert this to intervals. But before we do that, did it tell us what our number types are? It did not directly, but it did tell us what we're looking at. Because when we talk about an interval, we're talking about all the numbers that are less than negative 1 or all the numbers that are greater than negative 1. So since it's not technically specifying, what it's telling us is all real numbers, which is nice for set builder because we're going brace x bar, the set of all real numbers, such that. Now we need to fill it in. And as much as it would be nice to just grab all that and throw it in, if it had been intervals already, not intervals, but inequalities, if it had written it as an inequality to start with, we just throw the inequality in. We don't have to do anything to it. But unfortunately, these are not inequalities. We have to rewrite it as an inequality. Two ways we can do it. One, so if we look at negative infinity to negative 1, we're talking about all the values of x that are what? Smaller than negative 1 that are less than negative 1. Now we would say less than or equal to if the negative 1 had a bracket, yes? So for this first part here, x is less than negative 1. Now I said two methods. The other method is going back to our chart that we used the other day that we came up with on Wednesday. Because we can look at the four interval notations we have, yes? Which one does this match up to? Fourth one, yes? What's A taking the place of? Or negative 1 took the place of A, yes? Which means its interval form, or inequality form, we're going to place this A with negative 1, telling me x is less than, which is exactly what we got, yes? Now we need to do the other one, negative 1 to infinity. Anybody have an idea what this would be? X is greater than negative 1. Okay, we ready to put this into the set builder? Like I was saying, if they gave it as an inequality, we just put that inequality in. Questions on this here? Funny enough, we can actually write this simpler. Think about the numbers, or look at how this is describing the interval. We want all the numbers less than negative 1, yes? We also want all the numbers greater than negative 1. So if I drew this on a number line, this would be the less than negative 1, yes? If I added the other part in, we would go. So wait, what is it actually telling us? It can't be. Set of all real numbers x such that x is not equal to negative 1. That's really all that interval is saying. It just can't be negative 1. Not all of them will do that, but funny enough, that's how this one worked. Questions on this here? Be ready for the next one. This one looks like it might be the same. However, it's not. Because we have from negative infinity to negative 1 or 1 to infinity. So there is a gap. Because all the numbers between negative 1 and 1 are definitely not included. Negative 1 is, but 1 is not. Negative 1 has the bracket saying it is included. 1 has the parenthesis saying it's not included. Now for our set builder notation, we're still talking about the real numbers. So we can go brace x bar. How would we write our interval negative infinity to negative 1 as an inequality? X is less than or equal to negative 1. We don't have to write it outside the set builder. We can just write it straight in set builder. Because on the last one where we put it above it and then put it back in it, it was just, we wrote it twice. Nothing says we can't just put it straight in there. Or 1 to infinity. X is greater than 1. That's it. We ready for the next one? The set of all integers except -4. So we'd go what? Brace x, the e. X is an element of the integers such that what? X is not equal to -4. Questions on this here? We feel good with this here? All right, we're going to do, I think it's 2 more. 2, I think there's 3 more. We'll do 2 more of these. So these here, we're actually going to start thinking about doing set builder or not doing set builder. Because this here is the whole numbers 50 through 54. Can we list these here in the set? Is it doable to write this out? Yeah, because we can go brace, and our first number would be 50. And then 51, 52, 53, 54. That's it. Now we could have, if we wanted to do set builder, I would not do this with set builder, because we can go brace, x is an element of the whole number such that, now we've got to write that as an inequality, which is fine. That 50 is less than or equal to x is less than or equal to 54. We could have written that as fast, if not faster, just writing all 5 numbers out, than it is to actually write that out as set builder. Doesn't give us any more, doesn't give us any more detail in set builder than it did listed as a set. Yeah, I'll take either one. They are the same thing. Questions on this here? The real number 0 through 4. It's not possible to write the real number 0 through 4. We saw that the other day, yes? We didn't even get to 1 by listing them all out, let alone 4. So here we have to do set builder. Brace x bar, because we're talking about the real numbers, yes? Now 0 through 4 as an inequality, we actually just did this-ish. We have what? 0 less than or equal to x is less than or equal to 4. And when I said we just did this, I was really talking about 50 through 54. 0 through 4, 0 through 54. Same thing, different numbers. Questions on this here? You know what? The integer is 1,000, negative 1,000, not negative 1,000, negative 100 through 100. Well, we could try doing this, yes? Negative 100, negative 99, negative 98, negative 97. We really want to keep going too far after this? But have I set a pattern? So we can go dot, 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 yes? Because that pattern continues indefinitely. Or does it? We pick the pattern back up and finish it out. This dot, 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 where we start something, tell it keeps going, and then finish it, does show up throughout mathematics. And especially when we talk about general forms or the general form of an equation or setup, we do this dot, 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 saying it continues, and then show the end of it. We can also write this as an inequality. Same exact thing. There we go, make that Z a little nicer. Okay. Okay. Any questions on any of this here? Are you ready for the next piece? Homework. 5 through 14, 17 through 24, 26, 27. So 5 and 6, writing it as a set. Both of those are nicely writable. They have a set pattern. You can do that there. If you want to write it in set builder, you can write it in set builder. 7 through 14, you're writing it as an inequality. Not an inequality, sorry. As an interval. So you're converting it to interval form. Then 17 through 20, it says to graph the given information. Graph it on a number line. 21 through 24, 26, and 27 is writing it in set builder notation. And that's it. Also, that is the end of 1.1.